Okay, here we have to find the first and the second derivative. So let's find the first derivative first. This is, okay, there's a x there, x there. The first x multiplied by a, then power of e. Right, the second x multiplied by b, then entered into the sine function as an input. And the final thing is they were multiplied together. Okay, so the first thing you have to do is the product rule, because that's the last thing being done to the two functions. So differentiate this first, multiply by the second, multiply by the first, and differentiate the second one. So the derivative of that will be e to the power of ax times by the derivative of ax, which is just a. Okay, so the derivative of that will be cosine of beta x times by the derivative of beta x, which is another beta. Okay, so note that here we can factor out e to the power of ax. So let me do that. Okay, so that's the first derivative. Let's do the second derivative. It's going to be a little bit more complicated. Still, the first thing is the product between these two. So let me first differentiate that part. We get a e to the power of ax. Okay, let's multiply by the bracket. Exactly the same. Plus e to the power of ax. Differentiate by what's in the bracket. It's going to be constant, so a cosine of beta x, then chain by the derivative of beta x, which is going to give you beta. Okay, second part, beta, it's going to turn into a minus sine of beta x, that's the derivative of cosine. And then you got to differentiate, right, beta x, which will give you another beta. Okay, so we get beta squared there. All right, let me factor out e to the power of ax again. Okay, and let me multiply this a in, and we get a squared sine beta x, a beta cosine of beta x, a beta cosine of beta x, minus beta squared sine of beta x. Okay, I mean, if you want to clean up a little bit more, we could maybe factor out the cosine from these two and sine from those two. But I'm just going to leave it the way it is right now.